We still on 1.5?
1.6 from Friday. Okay. So we should be on example 3. Yes. Yep. So we started example 3. We almost got finished with example 3 before the bell rang, but we did not. Now, we'll start off with this here. So going back through this, so using a calculator to solve this, I think some of y'all got the answers. Yes. So we were just...
It's really tiny.
Yeah, I got 1.5.
You didn't grab notes yesterday.
So this problem here, we got pretty much to the end of it. Some of y'all might have got the answers, but we'll just start here. So going back through this and how we type this in a calculator. All right, guys, let's focus in. The first thing we had to do is write this as an augmented matrix. So our first row was 1, 1, 1, 2. And we had 2, 3, 1, 3, 1, negative 1, negative 2, negative 6. It is a 3 by 4. Now at this point here, we got the graphing calculator, we turned it on.
Oh, it's small.
And the first thing we did was go second matrix and then go over to edit, because the first thing we're wanting to do is type this matrix in. And once we went over to edit, we're going to hit enter. Now the first thing it wants us to type in is the dimensions of this matrix. Now it is a 3 by 4. So we can type 3, enter, 4, enter. And then we want to type the matrix in. So we'll type the first row in, which is 1, 1, 1, 2. And then we have 2, 3, 1, 3, 1, negative 1, negative 2, negative 6. And we do have to type the negative. We cannot type minus. It's going to throw up an error if we type a minus. Questions on how we type this in so far? Yes, sir.
For matrix A, it only is a 2 by 4.
So the first thing we type in are the dimensions. So up at the top, if it says 2 by 4, we would have to change the 2 to a 3. Any other questions? Do what? So you went second matrix. Yes? Then you went over to edit. And you hit enter for A. Yes? And then you typed in and made sure that it's a 3 by 4. And then you type each number in. And the nice thing is that after you type the number in, if you hit enter, it will move to the next spot. So we would do 1, enter, 1, enter, 1, enter, 2, enter. Yes? And you did it with all of them. Because you need to type the whole thing in. Once you get the whole thing typed in, we go second quit, second mode. Once you get the whole thing typed in, we want to quit out of this so that we can actually apply a property to it. We all good? Yeah. Okay. Now the next thing we're going to do is go second matrix, but this time we're going to go over 1 to math. So the second matrix, we're going to go over to math. Now what we want to find is the R, R, E, F. So we're going to go up or down and find R, R, E, F. Reduced row epsilon form. R, R, E, F. Once you have that selected, hit enter.
Scroll down.
Scroll up or down and find R, R, E, F. So we should be here. Now, do not hit enter at this point. Do not. Because the next thing we need to do is,
Scroll down.
now we need to select a matrix to put into this. So we at least at this screen here, yes? R, R, E, F, with it blinking next to it. Second matrix again. Now this first row is where we can recall the matrices. Now which one did we put it in as? A, yes? Since A is already selected, hit enter. So we have R, R, E, F, A, matrix A. Yes? So it should be showing this here. Once you get this here, hit enter.
When you press, can you do that?
Enter. Enter.
Got it.
Next map.
Enter.
Oh, second matrix.
So let's go second click.
You
Matrix.
were supposed to go back
Enter.
to the matrix.
Then second matrix. Enter.
Go back
So
to
that'll
the
recall that matrix. Enter. Because if we don't do the second quit, it's going to keep trying to put it back into that matrix. So after we put it in, we want a second quit to tell it we're done putting stuff in. Okay. Okay. I think you might be doing a different one.
We didn't pull my hair.
I was trying to say.
Don't worry, I'll waste this doing. I don't like white people.
Isn't there?
I hate people. Wow.
Because that might be one for another one, but does that make sense? So when we hit enter, does your matrix look like this here?
Yeah.
Yes? Matrix look like the one on the board? Yep. So let's look.
Oh no, mine does
Second
not.
matrix.
Mine says
So
negative.
3 by 4, so 1, 1, 1, 2. Well, the second equation was 2, 3, 1, 3, 1, negative 1, negative 2, negative 6. Mhm. So you just didn't have that second matrix line put in. Mhm.
Oh, okay, it's okay.
Okay, we'll do the next one. You can follow along with it. So, we all have a matrix that looks like this here, yes? Now, when we have this diagonal of ones here, because again, the first column, so negative 1, 1, 2. Once we did this, we got 1, 0, 0, negative 1, 0, 1, 0, 2, 0, 0, 1, 2. That should have been a 1. This was the final matrix we were looking at, yes? Now, the first column we plugged in as our x's, the second was y, z equals number, yes? So in the top row, that 1 in the x spot tells us that x, we have one x, we don't have a y, we don't have a z, and it equals 1. So x here is negative 1. The middle one, our y has a 1, and it's going to be equal to 1, and z is 2. Because x was in the first column, so x is 1 in that first row. So x is negative 1, y is 1, z is 2. So our solution is the point negative 1, 1, 2. That's our point. That is the solution. Since we did x, y, z, the final column is going to read x, y, z. X, y, z. Question? So z is 2, y is 1, x is negative 1. Because x, y, z, x, y, z, x, y. So x, y, z, because x was in the first column, y second, z third. So our first one is we have 1x plus 0y plus 0z equals negative 1, or x is negative 1. The middle one, we have 0x plus 1y plus 0z is 1, so y is 1. The last one, 0x plus 0y plus z equals 2, so z is 2. Questions? Huh? Are you sure? What doesn't make sense? Because what did we do? Because here it reduced it to this. So the left side we have 1, 0, 0, negative 1. The middle we have 0, 1, 0, 1, 0, 0, 1, 2. We good on how, this is what the calculator gave us, yes? Okay. Now, when we typed it in, what did we put in the first spot? All these here are the numbers in front of x. All these here are the numbers in front of y. All these numbers here are the numbers in front of z. And this is what each equation was equal to. So when it reduced it, we have, our x now has what number in front of it? So y has 0, z has 0. Well, we don't list either of these if we rewrote it back as an equation. The only thing we have on the left side of the equal sign is 1 what? 1x. And on the right-hand side we have, so this first line tells us x is equal to, that's it. The middle one, we have 0 in front of x and z. All we have is 1y on the left-hand side. And on the right-hand side we have, so y equals, and on the bottom, x and y both have 0. The only thing we have left is z, and it's equal to, so the x, y, z would be the point negative 1, 1, 2. That's it. Questions? Okay. Question?
So how does x become negative 1?
Where was 1?
So like x is 1 right there. There. So how does x become negative 1?
Because we're finding out what its value is. Because in the equation, x is not negative 1 or 1. Because what's the number in front of that x? 1. So we're putting here, we're not putting the values of x, y, z. We're putting the coefficients, we're putting the numbers in front of those values. Then the calculator is turning it into this form, this diagonal of 1s, and it'll tell us what each value is equal to. So it's not telling us here, we're not plugging in what the value of x, y, z is. We're putting the numbers in front of it. So we're letting the calculator do all the work. The first thing we're doing is writing an augmented matrix. We're putting the coefficients, the numbers in front of each variable, and what they're equal to into a matrix form. So when we look at this first equation, it is in the form x, y, z. The variables are in the right order. Now the number in front of x is 2. Number in front of y is, number in front of z is negative 1, and it's equal to 15. The second equation, 3, negative 9, 9, negative 12. And the last one is 4, negative 3, negative 1, and 19. Now the dimensions of this matrix are A3 by 4, because we have 3 rows and 4 columns. Now, it worked out for this here, but we do need to make sure each equation does have x, y, z on the left side and the number by itself on the right. So that when we plug it in, all these numbers are the numbers in front of x, all these numbers are the numbers in front of y, all the numbers here are the numbers in front of z, and the last column is what each of those equations were equal to. So we got that, we understand how to get there, yes? Now the next thing we're going to do is we're going to grab the graphing calculator. And we need to put this matrix C in. So we're going to go second matrix, over to edit, and hit enter. We're going to type this into the first matrix C. Now we're going to type the coefficients in. But before we do that, we do need to say that it is a 3 by 4, 3 rows, 4 columns. And the first row is going to be 2, 3, -1, 15. Our second row is going to be 3, -9, 9, -12. And the last row is going to be 4, -3, -1, 19. So -3, -1, 19? Yes. Yes. Because it is also in your paper. Because we're just writing in that there.
Press number, press enter, and then go on the next number.
Yeah.
See how the first one is 2? And then press 2, and then enter, and then 3, enter, -1, enter, and then 15, enter, and then you're back to the start. So do the second. Do the part.
Yep. Once you get the whole thing typed in, second quit. Once you get it all typed in, second quit. So what's interesting here is if we go math, enter, enter. Math, enter, enter will turn it back into fractions. Did everybody get it typed in? Yes?
And then you go to math.
So once you get it typed in, second quit. Second mode.
Yes.
Now we're going to go second matrix. We're going to go over 1. And we want to find R, R, E, F. And once we find it and have it selected, we're going to hit enter. Then we're going to do one more time, second matrix. And we're going to select the matrix that we put it in. Since we put it in as A, we'd hit it and then hit enter one more time. Missy? Okay. So we don't have a matrix C typed in yet. So go second matrix. Now we select the matrix C we put it in. Since we put it in as A, we can just hit enter one more time. Enter one more time. Did we all get a matrix E that looks like this here? So top to bottom is X to Z. So X is 5, Y is 1, Z is -2. So 5, 1. That's the solution. All right, guys, questions on this here? We ready for the next one? So I skipped 4, that's fine. So we're on to the next page, number 6. I actually skipped 4 and 5. We're going to look at number 6. So the first equation, we would have 3, 2, -5, -10. Our second equation, we'd have 6 for x, but is there a y value? No, so we have to plug it in as 0, -1 for z, and 8. The bottom equation, we'd have 0 for x, -1 for y, 3 for z, and -2. Since x was listed in one of the equations, it has to be listed in all 3. Since y was included in 1, Actually, two of them we need in all three. Questions on how we wrote the augmented matrix? Now again, we can come over to the calculator. We good? Still need to write this down? What goes up here? Okay. So when we type it in, we're going to go second matrix over to edit, and we'll still type this into the first matrixing. It would be a 3 by 4, and we need to type this augmented matrix in. So across the first row, we would have 3, 2, -5, -10, and then 6, 0, -1, 8, 0, -1, 3, -2. We all able to get that typed in? Because again, once we get it typed in, we're going to go second quit. Second matrix over to math. Go RREF. Second matrix, we're going to select our matrix. And hit enter. We all get something similar to this here. Yes? Now, if we notice one of these numbers is in a decimal, the others are in integers, yes? Now, there's a way to convert from decimal to fraction. Okay? We're going to hit math. You notice the first one is FRAC, it's telling it to go to fraction. Enter, enter. We'll convert everything to fractions, from decimals to fractions. So it's saying number 6 is -2/3, -34, -12. Math, enter, enter. We'll convert from decimal to fractions. Math, enter, enter. Yes. Yes. All right. So there's two that I want to look at before we go to the homework. One, if we do this here and get this matrix. Now, if you notice, the bottom row of this matrix is all zeros. So we type a matrix in, and we get a bottom row that is all zeros. That's telling us that it is infinitely many solutions, because what the bottom row is telling us is that 0 is equal to 0. It's an identity, so it works for infinitely many. Now, if you type this in and get one like this here, so we do have decimals. We can go math, enter, enter, and that's fine. But if we look at the bottom row again, this time we got 0, 0, 0, 1. What that's telling us is that 0 is equal to 1. So this here would be no solution. So if the bottom row is all zeros, I would look and make sure that neither of the rows above it gives us that 0 equals 1. But if that bottom row is all zeros, most likely it's going to be infinitely many. If that bottom row is all zeros and then a number, no solution. Questions on this here? We're good with this here. Homework. Problems 3 through 8, 11, 12, and then 13 through 19 odd. So 3 through 8, 11, 12, and then 13 through 19 odd. So 13 through 19 is 13, 15, 17, and 19. So 3 through 8. Problems 3 through 8, you want to write the augmented matrix for the system and state the dimensions. 3 through 8, that's all you're doing is writing the augmented matrix and stating the dimensions. Do make sure that the variables are in the correct order. 11 and 12 is error detection. So you want to look at 11 and 12 and see how they wrote the augmented matrix. 1, describe what they did. They probably switched something. And then rewrite it in the correct augmented matrix. 13 through 19 odd, 13 through 19 odd, so 13, 15, 17, and 19. You're going to use the graphing calculator to solve the system. And that's it. I would start on 13 through 19 odd since you have the calculators. You don't need the calculators for 3 through 8 or 11 and 12. You have the rest of the class time to work on that.